So now is the expectation or mean of random variable. What is expectation? Expectation is simply something that we hope to happen. We think that we think that it is going to happen. We have a strong will or a strong feeling that this thing is going to happen, and this feeling develops based on some data, right? If I see what can I do if I let me think of an example here. Okay, yeah. If I have a weighted dice that is heavier, and okay, if I have a ball that is heavy on one side, okay, it is heavy on one side and light on the other side. So if you try to roll it, if you try to keep it somewhere, so you what you'll expect is that it will roll towards the heavier side. Okay, you'll expect that it will roll towards the heavier side. Okay, so this is the basic concept of expectation or mean of random variable. Mean of random variable. Why am I saying mean? Because when we take mean of something, when we have a value here and we take mean of anything, there are these values and we take mean of them. We take a number, we find a number, a value that can represent them all, that can represent all of our data. We try to find a value. Mean is just a value that can represent all our data. Okay, it can it what is actually saying that when we find the mean, what we do is that it can be used to represent the lowermost data, the lowest data also, and the highest data also. It can You can consider it as the central tendency. So, yeah, it is central tendency of our data or of a distribution, whatever you can say. Okay, so this is what yeah, this mean means. Okay, and when I take the mean of random variable, what will I get? I'll get the probability. Actually, I'll get it. I'll get the expectation. I'll get something that will represent the random variable. I'll get some value that will represent the random variable. That will we can consider it that if we do an event, if any event occurs, then this value is most expected. This is something that you expect. Okay, this thing is representing the random variable. Okay, all the random variables, it is representing it. And if this thing might don't make sense, just relate to it, try to relate it with the statistics thing that I told you here. Okay, so now let us get back to this probability part of expectation. What happens is that when we take the mean of a discrete random variable x, it is the average of all possible values that a random variable can take. So it is just we are just finding a number to represent our mean of random variable, right? So the mean of the random variable weighs each outcome xi according to its probability. The common symbol for mean is this random variable is mu here, right? Now what this line meant is very important. It is saying that it weighs. Now what is weighs, or what is weighing something, or what is weightage? But actually this the central idea of this thing is this weight thing is that we are trying to differentiate, discriminate between things on some specific criteria. Here this criteria becomes probability. We are discriminating between each of these x1 xi's, or I can say each of the value that random variable can take. I am discriminating between them. I am putting something forward and pushing some things back. I'm taking the value of something high, and I'm expecting it more than the others, because based on their probability. So this is what this line means. This mean of random variable weights each outcome. This line means. Okay, now the formula for this mean of random variable expectation is mu x is equals to x1 p1 plus x2 p2 up to xk pk, which is simply summation of xi pi. You can understand what is it is written here. So it is simply weighing all these terms, these possible values that x can take. It is weighing it based on the probability, this p term here. So p here is probability. It is probability of xi. So it is probability of xi here. Okay, these p terms. So this was our expectation. Now if I had to take an example, let me take an example now. So If I am taking an example, I'm going to toss a dice 3 times. I'm going to toss a coin 3 times. So our sample space for it will have heads, 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 tail, and heads, tails, tails, and heads, tails, heads. Then I'll be having tails, tails, heads, then tails, heads, heads, then tails, heads, tails, and then tails, tails, tails. So this is a possible outcome. Sample space. These are possible sample space. Now what I'm going to do is I'm taking a random variable now RV for okay. I don't write RV here. I'll write it as X, capital X, that uh, which is defined as it is acting on Fi, and it is defined as number of heads. I'm saying number of heads. Simple example that I always take. It's number of heads. So what is X value of X? What is the value of X now? For first one, the number of heads are three, right? So number of heads are three. So the value will become X. This XRV will become three. And if the value is 2 for this one, there are two heads here, and there are two heads here. So for all these three, H H T for and H T H, and for where it is THH, and so for these three, the value of X is 2, and then comes the value of X is 1 in this one, this one, and this one. So HT, T, T, TH, and THT, they have value 1, and if I take X of TTT, it's 0. So I get a random variable of varying possibilities. I have different numbers now here. Okay, so this now if I have to find this expectation, so what will the sorry now if I have to find the probability, let me find the probability first. So if I have a random variable X, let me draw it like this. It is it's more easier and better way of representation. So I do it like this. If I have random variable this, and then the value of pxx will be, then the probability of this random any random variable will be, if I have 3 here, the random variable 3, then what is the probability of hhh? It is probability of hhh is how many outcomes are there, simply 1 2 3 4 5 6 7 8 8. So probability of every single outcome is 1 by 8. So probability here becomes 1 by 8 for this. For 2, if the value is 2, then what is the out probability, what is the outcome here is, this is simply this it will be 1 by 8 plus 1 by 8 plus 1 by 8, it will be 3 by 8. Why is it so? Because of additivity rule. Simple thing, you can work it out. You do push your head into it, you will understand it. Then if the random variable is 1, again it will be 3 by 8, and if it is 0, the random variable will become 1 by 8 again. Now see, their sum should be equals to 1. Is it 1 by 8 plus 3 by 8 into 2, because 2 times it is here and 2 times it is 1 by 8 is here. So it is simply 2 plus 6 upon 8, which is equals to 1, because this will become 8, right? So it is 1. So we are correct. We are doing right. We are doing fine here. Okay, so let me just erase this part. Now what I'm going to do, I found probability here. We are actually revising some. You can understand it as a revision till now. Now we are going to find the expectation here. Okay, I'm going to find the expectation. Just have some space again. Yeah. So if I had to find expectation, the formula for expectation is the expectation here, mu of of x here is x1 p1 xip. I can see write it as summation xipi, simple thing, right? This is the formula. So here in this case, the probability will become, what will the probability become? Let me write it here. Sorry, the expectation become the mu will become, will be equal to what is the random variable here? The random variable 3, and its probability is 1 by 8, plus random variable 2 probability 3 by 8, plus random variable 1 probability is 3 by 8, random variable 0, probability 1 by 8. Now if I add this, if I am adding this, solving this, I am if I'm solving this out, what am I getting? This will become 0, this will be 3 by 8, this will be 3 by 8, this will be 6 by 8, and this will be 3 by 8. If I solve it, what do I get? 6 3 6 6 it will become 12 by 8, I guess. Yeah, am I correct? 3 yeah. Now if I solve this, I'm gonna get 4 3s are 12 and 4 2. I'm going to get the value 1.5. Now is it possible? If you look at it, am I going to get 1.5 value anywhere? Is there random value? It is actually, it is showing the value of random variable. It is telling us that which random variable is possible, which random variable is expected, which random variable can you expect. But there is no random variable that can show this value. Now comes something called variance, which we are going to study. Because see, what will happen, that either the value of random variable, okay, it will be, but this expectation is saying that it will be close to 1. It will either be 1, it will either be 2, right? Because they are the closest possible values that this random variable is taking here, right? So this is what expectation does. This is what expectation means. It is a number. It will not always be a whole number. It can be fraction, and it cannot always be a random variable that you see up here. But using this, you can actually understand, you can predict that what random variable are you going to expect, what random variable is going to come. You can expect which random